All right, in this video, we are going to talk about the average rate of change of a function. So if I have a function f of x, to calculate the average rate of change of the function over the interval from a to b, then it's given by this expression right here. It's f of b minus f of a over b minus a. So the way that you can look at this, basically, right, is that a and b are you can think about those as being along the x-axis, and when you do b minus a, right, that is the distance on the x-axis from a to b. Okay, so that's basically how much the x numbers have changed. And then f of b and f of a would be the points on the graph, are the y coordinates of the points on the graph corresponding to a and b. So this would be the y coordinate of the point whose first coordinate is b. And same thing for this. This would be the y coordinate of the point on the graph whose x coordinate is a. And so basically on the top is the difference between the y coordinates. So this would be the distance between the x coordinates. This would be the distance between the y coordinates. So how much the function goes up divided by how much the function goes over to the right. Okay, and this could be up or down. So that probably sounds a lot like slope to you, and it is similar to that. Right, when we calculated slope, it was change in y over change in x, but slope really is only for lines, right? And this average rate of change can apply to functions whose graphs are not lines. All right, so let's first look how to calculate this when we are talking about when we're given a function in function notation. All right, so let's say we have this function f of x equals minus 2 x squared minus 4x plus 1. And we want to calculate the average rate of change from negative 1 to 8. Okay, so the formula, right, for the average rate of change over the over an interval is f of b minus f of a all over b minus a. Like so. In this case, right, 8 would be playing the role of b, and negative 1 would be playing the role of a. All right, so it would be f of minus 8, or sorry, f of 8 minus f of minus 1 on top. On the bottom, it would be 8 minus negative 1. Okay. Okay, so on the bottom part, that's pretty straightforward. On the top, we're going to have to figure out what f of 8 is and what f of minus 1 is. All right, so let's go ahead and do that. I just kind of like to do it separately. You can kind of do it all at once if you want to, but to me it just is a little bit easier if we look at it separately, in my opinion. All right, so f of 8 is going to be 2 times 8 squared minus 4 times 8 plus 1. And I'm going to go ahead and just calculate that out. So that would be negative 2 times 64 minus 32 plus 1. And so it's going to be negative 128 minus 32 plus 1. So that is minus 160 plus 1. And so that is negative 159. Okay. All right. So that is f of 8. Next, we would calculate f of minus 1. All right, f of minus 1 is going to be, right, we're plugging negative 1 into this function here, so that's negative 1 squared minus 4 times negative 1 plus 1. So that's going to be negative 2. Negative 1 squared is positive 1. Negative 4 times negative 1 is positive 4. So minus 2 plus 4 plus 1. That's going to come out to be 3, right? Okay. So now going back over here, right, we know that f of negative 8 is negative 159. And then we're going to subtract off this 3. And on the bottom, we have 8 plus 1, right? 8 minus a negative 1 is the same as 8 plus 1. So we get minus 162 over 9 on the bottom. And let's see, that is going to be negative 18, right? If you do that out, right? So the average rate of change, right, is negative 18, right? So you can kind of see that here, right, when we did 8 minus a negative 1, we got a 9 on the bottom. So that's how much the distance on the number line from negative 1 to 8 would be 9 units there. And then these would correspond to the points on the graph, how much the difference in the y-coordinates are. So from 3 to negative 159 would be negative 162. So this function, if you look at these 2 points on the graph, the distance between their x-coordinates would be 9, and the distance between their y-coordinates would be negative 162. So the average rate of change is negative 18. Okay. Just to make that a little clearer, let's take a look at a point where it's on the graph here. So here they give us the graph, right, and they ask us to calculate the average rate of change from negative 4 to 2, okay? So let me get this so I can just draw over this pretty easily. All right, so from negative 4 to 2. So negative 4 is right here, right, on the x-axis. 2 is right over here on the x-axis. And so what I want to do, right, we know that the formula for the average rate of change, right, is f of b minus f of a over b minus a. And in this case, right, we know that our a would be negative 4 and our b would be 2, right? So this would be f of 2 minus f of a. So that would be negative 4 over b minus a, right? So 2 minus a negative 4. All right. In the last example, we had the formula, right, for our function. So we just plugged in b and a, right, for our formula. We don't have that here, right? All we have is the graph. So what we'll have to do is use the graph to get what these things are. So first off, f of 2, right? If I go and look at where 2 is on the x-axis and I go up or down, right, looking for where the graph is, I can see, hey, the point on the graph right here corresponding to 2 would be right here, okay? And that point would be from the graph, right? 2 would be the x number, the y number would be 0, okay? All right, so that tells us, right, that f of 2 is equal to 0. In other words, if we had the formula, right, for this function, we don't, right? But if we did, and we plugged in a 2 for x, that would give us a y of 0, okay? Right, because it is a point on the graph. So we know that would be 0 right here. All right, next up is f of negative 4. We need to calculate that out. So again, what we would do is locate -4 on the x-axis and go up or down, in this case down, right, until we hit the graph of the function. And we can see this is where the graph of the function is, okay? And then what we would do is look at the y-coordinate, right, which in this case is -3. So this point, right, has an x-coordinate of -4, has a y-coordinate of -3, right? Because if we go straight over, that's where we are on the graph. So that would tell us that f of -4 is equal to -3, okay? So I have 0 minus a -3. Okay, and then 2 minus a -4 is the same as 2 plus 4. All right, and on top I get 0 plus 3. On the bottom I get 6. So 3 over 6. And simplify that out, I get 1/2 as the average rate of change. All right, so you can do that by looking at the points on the graph, assuming you know that the points are pretty easy to figure out what the y-coordinates are here, which they should be on the problems that we do on the homework. All right, so let's take a look and one more thing related to this problem. Here, right, I have the points already calculated out, right? Okay. And you can see where the points are at -4. It's this point here and this point here at 2. And you can see I've drawn a line through those 2 points, right? So if I go and I look here and make this little triangle, I'm going to have to capture this image before I write on it. So if I look right here at this little triangle, kind of formed by those 2 points, right? And I calculate the change in y, right, over the change in x. The change in y is 1, 2, 3. Right? The change in x is 1, 2, 3, 4, 5, 6, right? So it looks like that. All right, and so the slope of that line, right, would be 3 over 6, which is 1/2. All right, and so you can see it's no coincidence, right, that over here when we made this calculation, right, with the average rate of change, that we got a 3 on top and a 6 on the bottom. So pretty much what you're doing when you are making this average rate of change calculation, right, is you're taking 2 points on the graph of a function that may not be a line, right, and you are putting a line through those 2 points and calculating the slope of what that line would be. So that would be the average rate of change, right? The x coordinate changed by 6, right, and the y coordinate changed by 3. All right, so it is related to the slope of the line and kind of a generalization of that concept. Okay, and the only one of the differences is for a line, right? It's always going to be the same, that calculation, no matter what 2 points you pick, right? But for a function whose graph is not a line, it's going to be different if you pick different points. Okay. All right, so that's it for average rate of change.